So question 2. I've been told that the intersection of R and S is equal to 0. So visually I've got a situation where I've got two sets with no intersection. So no overlap. So I know that they are mutually exclusive. They can't happen at the same time. So a statement would be R and S have to be mutually exclusive. In part B I'm given some information about probability. So I've got probability of A is a quarter, and the union of A and B, I've been given the fact that that's 2/3. And the first bit of the question, probability of B, I've got to find. Now the critical information here, noticing, is that A and B are independent. So independent means that the intersection of A and B is equal to the product. The events don't affect each other. So I can actually work out the intersection of A and B by getting the probability of A times the probability of B, which is unknown. I can also use the addition law. The union of A and B is equal to A plus B, take away the intersection. So that's going to help me find P of B, because I know the union is equal to 2/3. I know the probability of A, that's a quarter. Don't know B, but I do know the intersection is called probability B. So I'm now going to rearrange. 2/3 take a quarter is equal to 3/4, the probability of B. 2/3 take away a quarter is equal to 5/12. This 3/4 the probability of B. In other words, probability of B equals 5/12 divided by 3/4, which is 5/9. So I'm now looking at 2 parts C, where I was being asked to find the probability of it not being A intersected with B. I'm looking at that and thinking, can I identify on the Venn diagram which piece that is? Because if I can, that makes the whole job loads easier. So not A, I'm going to just colour not A and highlight it this way. So anything outside A. And then anything in B, I'm going to go the other way. So that's anything in circle P. So I'm going vertically now. And my intersection is where both colours appear. So they both appear in this piece. In other words, B, take away the intersection. So I know that ultimately to get probability of not A intersected with B, I want to get the probability of B, the whole circle, take off the intersection. Now what have I got that's going to help me? Well, previously I worked out A, I worked out the union, I worked out B. I'm just working out the intersection now. It's a quarter probability B, so it becomes 5/36. So now I've got all the data I need. I've got the probability of B, which is 5/9, take away the intersection, which is 5/36. When I put that together, I'm going to get myself 5/12. Now moving on to part D. So part D is a conditional probability. I know it straight away because I'm looking at that line, that oblique line. That's my given. So I want my probability that not B happens, so B doesn't happen, given that A has already happened. So I'm limiting my sample space. I'm using my laws of probability, conditional probability laws now. So the laws of conditional probability say that I want the probability of the intersection of the two sets divided by the one that's already happened. So that'd be A. So to get my numerator, so probability that it's not B intersected with A, I can look at my Venn diagram again. It's the same principle as part C really. So not B would be anything outside B. So anything outside B. A would be anything in A. So I'm vertically going to colour A. And now I'm looking for the intersection, so I'm looking for where both of those colours are, which is obviously this piece here. So that top bit is the same as saying the probability of A, take away the intersection. And I've got to divide that by the probability of A. So numerically I've got probability of A, which is equal to a quarter, take away the intersection, which I worked out previously, that was 5/36, divided by the fact that A's already happened, so that's a quarter. Put all that together and I end up with 4/9.